Yeah, so this is going to be another exercise. This was what we call a switch bistable. That's a program we are going to make. And here's a little background. And as an example, we can use, for instance, a valve or something here. Yeah, you can see down here, a valve looks like something like this. It's open or closed. So is field legacy wiring if the valve is not smart, which is why I'm using digital input and digital outputs, and then it's a little about simulation of a valve like this for testing. So the wiring here is a valve from some suppliers. So they have feedbacks and you have control signals, and there's a motor controlled here too. So there would have to be relay output, digital output here, or you would need interface relays for this one. So you can shut it and you can stop it in the middle, and then it's fully open. And of course, this one can stop somewhere in between too. And then fully closed and fully open signal and a command. And here's how to wire this 24 volts out. And we turn into a digital input, and we can read those as a couple of bits in a register input image, and then we can write to a couple of bits in the output image, which then would switch these relays, or two relays on and off. It's only shown one relay and one optocoupler input with the 24 volts. And then we have our valve control block, which called we are going to call it FB switch bistable or something like that. And here are some inputs and outputs from it. And here are the outputs here too. And it's going to be a state machine, or should be a state machine. This control outputs could either be active when the valve is opening or closing, high or low. Or if you're using only one output, we have to keep one output steady high. If this valve was of the type where you have to keep it open or close dependent, and then it would, when you remove the control signals, it would shut or open depending upon whether it's fail to close or fail to open. So there's an option in the program here, that indicates parameter steady outputs. Yeah. The PLC control with the simulation here. Here is PLC control and wiring, and here is PLC control and simulation. Then we have a valve simulator of some sort, and then we write to this image. Of course, these modules are not here, but the input image here is not located on the DI module. That's a part of the CPU itself that we keep. So our simulator reads the outputs and does whatever valve should do. And here you can put some parameter into this function, the switches. We can set the opening and closing time and so on. And here's the valve control as just was on the previous page. And then we are looking at this norm, the IEC 63131 from 2017. They specify a valve control block or switch binary valve. And here are some feedbacks: automatic high and low, outside high and low, external fault, lock safe and high and low, force signal high and low, force disable high, force disable low, force block, force suppress, lock automatic, lock manual, lock outside. From operator station, you've got something, commands, and then it states outputs to the operator station, inputs, arguments on the left-hand side, results or outputs on the right-hand side. And here is for operating system, block, suppress, disable, opening, closing, alarms and faults, and so on. That they should show on the conflict too. If you're safeguarding, and if you force it shut and it should be open, you get conflict fault. So this is a normal function output, which is true when it should be open. There's always positive logic here. And here are the pulsed outputs. Of course, you would need one. You could use one of these. The failed, binary confirmed high, binary confirmed low, binary state of safeguarding, binary state block, binary state suppressed, automatic, and outside mode. And here are some parameters that's suggested. One parameter code to be defined. If used on terminal, it shall then start with the letter P, always P. So all the parameters, what you call them, but the first letter should be P, and there's something here. So what do we have? Yeah, there's a traveling time, default values, pulse length, if you use those. Starter mode, which means that you restart your PLC or an instance is loaded fresh onto your PLC. So it should start up in closed, open state or based on feedback. The sensible thing to do is usually based on feedback. But okay, default is it should start up and go to closed if it's open, and so on. There are some other options too here. Well, that was it. Yeah, so this was a little background on how a valve could be controlled and something like that, or how to control a valve. Yeah, and what we looked at is how to simulate it, and we looked at valve control according to a norm that we have here too.